Hey guys, Daniel here, aka HashLips, and welcome back to a very exciting video. In this video, we're going to be doing something very special. So I am very excited that you are joining me on this journey, and it's been a long journey. And at this stage of our journey, we're going to come to the completion of what we wanted to create. Now, if you go to the GitHub repository, going to github/hashlips, you'll see that our generative code program has been forked and started so many times. We are focusing on the generative art open source program because this is the one that I want people to contribute to. Just a side note, when I said that, I realized that I'm busy making these videos, and even though I would love to pull in everyone's pull request at this stage, I'm not going to do it yet. And the reason for that is because the videos show particular code, and if we do the pull requests, people will not know what the updates was. But that being said, these pull requests will be considered and pulled in once we are ready to hand this off to the world, and then the world can run with it. But speaking about the world, I've got an important announcement to make, and just want to say a very special thank you to the sponsor of this video, which is Lunaland. And I say sponsor in a very interesting way. I've been approached by Lunaland, and the guys at Lunaland, even all three of the guys who started Lunaland, I got to chat to on a meeting tonight, and it was very exciting to just hear from them and the passion that they have for this project. Lunaland is obviously a decentralized, hyper-deflationary peer-to-peer digital currency, and you guys can read up more about it. Go to lunaland.io and go and check them out. These guys really are making something amazing. And not only is this coin very cool to hold, but you get rewarded. And that's the best thing about Lunaland. As you get rewarded, you can see you get up to 10% on every burn. And they have these special burns, which is every full moon, coins gets distributed. They have special NFTs, which we'll talk about more today, and a lot of things happening. I believe there's games. You guys should really just go and follow Lunaland, go and see what they do. If you go right to the top of the website, you'll see their links up here, and you can go to their Twitter page. They'll keep you up to date with all the latest news. They have giveaways, they have airdrops coming. It's a really exciting project that recently started, and I can honestly say that the creators of the token, they are doxed. They are everywhere. They're having AMAs. They're really a fun team. And from the short time that I got to spend with them and getting to know them, I can really say they are solid people, and really made my day by actually giving me the opportunity to incorporate them in this video. And how are we going to incorporate them? Well, we are going to adapt the code that we have been making. We're going to do an update, a very special update. This might or might not be the very last update that we do on the code generative art program. And the reason for that is because we want to now take this code that we have and show you how you can adapt it to a unique project, such as Lunaland. Lunaland needs these NFTs, and they have already created so much or put in so much effort in creating the artworks, and now they want me to bring it all together and create the 10,000 series. Well, in this episode, I'm going to be showing you how we're going to be adapting our code base, because previously we did the rarity weights, but for Lunaland's use case, we have to update it and make it a bit more special. The reason the way we're going to make it a bit more special is interesting. We will actually have to work with different races, such as alien, human race, zombie, there's a bunch of races, and they all have rarities. So we're going to look at how we can update our code, how you can update your code, and I'm going to include some of the files in this last update. So if you pull down this repo from GitHub, make sure you're going to be on v3 branch to get the latest updates and to follow along. And lastly, I just want to thank everyone for being so supportive and on the journey that we've walked together. If you're new to the channel, go and check out this playlist. I'm sure you'll find it very valuable. And the things we teach, we really try and go into depth. So without further ado, how they might say, let's get started and let's go and check what's the use case for Lunaland and their amazing NFTs. So how can we start incorporating that and actually start minting and building up these amazing artworks? Up until this point, you have seen this code and you know what it's doing. It's selecting the rarities based off weights. Now, in our special use case, if we just take a little bit of a second and look at how Lunaland's NFTs look like, right? Lunaland has this special, unique style on the NFTs, and I actually have the actual beautiful designs that Errol designed for me and gave me access to. So we're going to be using these attributes that's already been created, and the things that you guys don't know is there's going to be very special NFTs, but we work with basic races such as a zombie, human, there's alien, there's particles, and each one of these races have a rarity associated to them. So at the end of the day, we are looking for something like this. Our result should resemble that. And this is where we're going to kick off and start off by basically implementing the races first and then work our way through how would we do the rarity from there. Looking at the code, and what we've updated is simply only in the inputs folder. You'll see inside the inputs folder there's now alien, censored, human, particle skull, and zombie. These are the different races that we are going to be using as a first level filter what we need to render. These races can also kind of vary in rarity. For example, an alien is much more rare than a human and so on. But we have to implement that now in a much different way. We can also see that each one of these folders contains subfolders with the layers that you used to see. We no longer have the rarities inside, such as super rare, rare, and original inside the folders. We just basically have the attributes again, like we did in the original code, but now with the added layers of the races. And so we adapt the code to be more flexible and more malleable. Because from this point onwards, you can customize this code to your needs and run it for your project. And that's what we're busy doing here. I believe you guys are going to learn a tremendous amount in this episode just by working with the code and getting these rarities up and running. Now, there is a big table that we can follow that explains the rarities to me. I'm going to explain them as we go along, but I'm sure you guys are going to enjoy seeing how we can fit everything together. But yes, so this is one of the backgrounds that we're going to use, and on our side, we need to now determine which ones are rare and super rare, and that we'll get to. Like I mentioned, we are going to have to scale a bit down in our proficiency of setting up the config file.js. We're actually going to have to list each and every attribute for each and every race because we want fine-grained control. And that's what we're going to be doing first. I just want to add that this is going to be a true live session coding, seeing that this I do on the fly. So we're going to be debugging, making mistakes along the way, but follow along and you'll learn a lot, like I said. Let's go ahead and let's change the way that rarities are actually looked at. Well, first of all, we are now going to link the rarities to each element, and we have to define the races first. So without breaking anything, I'm just going to add to the code here and we'll clean it up later. What you can do first is define a constant variable and let's call it maybe races, right? Then what we can do is equal this to an object or an array. Let me think about it. Let's do an array. Perfect. It's going to be much very similar to this basically, because we also want to specify from which one to which one we're going to kind of mint or create, because we want to be able to say that we want 15 aliens, we want, I don't know, 20 humans, or whatever the case might be. The rarities are going to vary in the final product, but whatever we're doing here, it's just for an example. So what we can start off with is kind of the most rare one. And I think the most rare one is the censored. I believe it is the censored one. But we're going to start off with the censored one, and then we're going to continue. Along the way for each one. So let's go and do that. I have just skipped ahead a little bit, and this is basically what we created. I created an object for each one of these races, and we have censored first particle, alien, zombie, skull, and human. And then each one is just from 1 to 1. We'll update these values as we go along. But here's where the magic happens. So we're going to kind of use the same concept where we also have the last one, which was our original for the rarity. We're just going to make the human the last one and call it the same, where the to field will be equal to the edition size. Humans are going to be the most popular one, or the most available race, which is fine. And then that's why we have it last, right? And the ones going up here, they range from the most rarest to the least rarest, okay? Perfect. Next, what we can do is actually now get rid of the rarity weights like we said we're going to do, and let's up the edition size. I'm going to up the edition size to 50, just to give it a bit bigger edition size. And then we're going to set up these values so that we actually have something to mint. And we're going to do it without thinking too much about it, but let's just go for it and let's see what happens. Let's say that we want 2 censored. So we're going to make this from 1 to 2. ID 1 to 2 means that we will have 2 NFTs over there. Then we want to go from, for particle, from 3, because you can't go from 2, otherwise it will overwrite it. So you want to go from 3 up until, let's maybe make it 6. So we know that there's going to be 3 of them. And then for alien, 7 to, let's make it 12. 7 to 12. And then for zombie, we want to take 13 to 20 maybe. Maybe 25. And then skull should be 26. And then this one, we can just make the 6 to 40. I'm just making this all up, but as we go along. Anyway, human's going to be from 41 to edition size. So just to keep it to a real world example, I'm going to make this into maybe 60 or 70 edition for now. Maybe let's do it a round number, 100. Perfect. So that's what we've done now, and this is the only thing that we need to kind of specify how many of each race do we want. And we already have the sufficient folders with the attributes on each of them. So if you see, there's the folder structure, and there's an alien shoulder, there's a Fiat, and there's also the Luna logo. So we already have these in our folder structures defined. But something interesting to note is in each one of these folders, you can see that there's a background, a suit, a shoulder, a pin, a facial hair, mask, hair, and accessories. Now, each one of these races are going to have each one of these folders and each one of these layers inside them. And the reason for that is, with some races, some attributes might not work. For instance, on an alien, we don't want to put facial hair. So on the alien field, we'll probably remove the goatee and all these facial hair features, but maybe only leave no facial hair there. And that's something that we're going to refine, but we first want to set up the whole project, and then we'll refine the folders so that you guys can see how I do that as well. Perfect. So now let's carry on. The next part that we want to do is actually redefine our layers. Currently, our layers are so nicely defined, explaining exactly where they sit and automatically getting back the elements. Now, we have to unfortunately discard of this amazing method and by hand type out a bunch of lines of code. Unfortunately, at this point, this is what we're going to have to do to get the most finest grain control over each element. But luckily, you only have to set this up once. And once you've set this up, you can run the program, 10,000 times, which is beneficial at least. But let's get going and let's set that up. We're going to have to start with layers actually having the races inside them first. So in order to complete this, we've always worked with the layers file, and that's all we worked with. Just a side note, I'm going to be doing this all in one file, but it's much more advisable to split this up because it is going to be a lot of code and repetition, especially because we want to go into a fine-grained space. Anyway, what we're going to do is we're going to define a variable and call it races here as well. But now we actually have a name conflict, so we're going to call this race weights. Okay, so this we'll call race weights, and here we'll actually have the races down here. So the first thing that you want to do is specify the races one by one. Now, for example, you will say there's the alien race, and inside the alien race, it's going to have a few things. Now, what we can do at this point is specify the layers in each one of these races. So we can say there's layers, and the layers, they're going to equal to an array, much like we have here, but we're going to specify them a bit differently as well. We want to actually also have a name, because this name will actually be kind of the race name. We might use it, we also might not use it, but it's good to have it in here. So we're going to put alien in there. Next, what we want to do is now specify an object which is going to look very similar to this. So let's go and grab that. So let's go and grab this whole object and put it inside one. And we're not going to do this anymore because we don't have that rarities. Remember, we're moving this all one layer up. So what we can do is elements will now actually only be an array, like so. And that array will contain each and every level of complexity, rarity, and percentage that it needs. How did our arrays look before, and what did this function return to us? Well, if we look at the function, it took in a path, it cleaned out the name, and then it actually went to go and put these two as an element. We're going to take this and we're going to put this inside our elements array as a single file, and we're going to leave the path as it is. But now we're probably going to have to specify the path like so. So we'll replace this over there, and what this basically tells us is that we need a directory, and then inside the directory we're going to have the rest. Now inside this directory, because this is the alien race, this will be alien, and then / and then we have to specify each one of these elements, right? But now this is for the layers, so this is going to be an element inside a layer. So let's just think about this carefully. We have got our layers, and then we've got the elements inside each layer. So I think a good point and a good thing to do at this point is give the layer a name as well. For instance, we can call this the background layer, because then we won't get confused with what we are doing. So inside this directory, inside the alien file, we're going to reference this background layer, which is one-background. Next, we need to go and see what's inside this background to go and specify it. This is why this code was so nice. It actually automatically did this for us and made an array. Well, this time we want that control, so we have to specify it ourselves. We can see that we have got a blue.png and electric and then a hypno, which we're going to define now. So we're going to say there's a blue.png, and that's going to be this element. Now, it's also a good idea to give it a name because we don't have this function anymore. We can most probably create a function again for us to specify this, but at this point, you'll just kind of type in the name that you want if this attribute was selected. The next thing that we do want is a percentage. Now this percentage is kind of the weight that it would use, kind of for it to be used. Even though this is a percentage, I'm going to refer to it as a weight. And the weight will be anything out of 100%, right? But let's say the background here can get chosen 25% of the time. And you'll see how we're going to work with this later. But now we have to do this for each and every layer inside this folder or in this element, which we have to do 3 times because there's 3 in there. And next we're going to specify the electric, and we're going to copy and paste that like that. Electric, yes, like so. And then we have the hypno. So let's put that there. So technically, what we should have is a nicely defined race, which is alien. Inside there, we specify the race's name, and then we go into the layers. So each race will have its own layers, and then in each layer, it will have an object, and it will have multiple of these objects, specifying the name of that layer and the elements listed out with a weight that we want to control it by. So we know that this will only be 10%, and then this one will also be maybe 5% because it's very rare. You have to kind of make sure that all the elements in this array equals up to 100. So if you only have 3, make sure they all equal up to 100. So for instance, if this was down here 10 and 10, then this would technically need to be 80% of the time. And that's how we're going to work with it. Now we still need to kind of run through this and see if this is going to work. But at the end of the day, it should work, it should be fine. And there would be a specific way of handling this. I think we need to put the most rare ones at the top or at the bottom. I'll have a think through that now and let you know. But I'm going to go ahead now and do this for each and every one. So just remember, I'm going to be copying this whole section over there and then duplicating it. Well, not this has already been done, but now for the layers, I'm going to take each layer and going to add it. And it's going to take me a while, and that's why I said it's better to separate these files, but I want to do it in one so that everything is understood as we go along. There is something I do want to mention before we carry on, and that is to actually give another field to these elements, and that would be an ID field. The reason for that, and the reason why we need to give an ID, is because we are going to use it in some cases where we need to exclude some of the elements, but still get the same ID value. For instance, the background of the element blue should always be ID 0. For the electric, it would be 1. It is technically the same that it is in the array, but not truly. It might appear like that. But if we were to take out this in another race, we know that we have ID 0 and ID 2 that's available to another race. So just keep that in mind. And then the last thing I want you to know is that once it comes to the time where we have to work out the rarities, we're going to generate a number between 1 and 100, or 0 and 100. And that number, we're going to say, if this number is greater than our weight, it should add this element. And if that's the case, then it will go and add it. That's why you need to add the elements that has the most weight up here and the elements that has the least weight down here. Also, just to be sure that a rarity will not override another rarity, you kind of have to make them separate weights. So for instance, there needs to be a weight not the same, if I can put it like that, but still equal 100 in all the element layers. And lastly, what you want to do is you want to take 100 and minus it of your weight. And that way, we'll actually get the true weight that we need. So, for instance, the weight here is 15, but once we minus it, it will be the remainder. So in this case of 100 minus 80 is 20, and that would be the weight for all the blues, and so on. But we don't have to specify it here. The reason for that is we can specify it once we render the actual elements. I just want you to take that into consideration so that once we get to that part of the code and I mention it, you know which parts of the code it will influence. So let me go ahead and do the rest of the layers. It's been a while and I've added all the races, and you'll see that array starts off with the alien race. I've only added the alien race. This is what I'm going to use to test with before adding all the rest of the layers. We're not going to need this layer element anymore, so we might as well delete it. So I'm going to remove all the layers, only keep the races in there, and make sure that I export them. So I'm going to export the races and also the race weights, which we declared here at the top. For the time being, I'm going to change this to only do 12 and then comment out the rest as well. We'll put them back as we place back the rest of the races with their elements. Just to go back to the elements down here, for the races, we have the alien object in there where we will append all the rest of the races in here. But if you open the alien race, you'll see that it consists of a name and a layers key. The layers key is just a normal array of all the layers, like we had before. But before, we generated the layers elements array dynamically with the code. So it looks very similar to what we had before, but here we have to manually actually grab each one of the layers. Which brings us to, we can actually remove this now, and let's go ahead and remove it. Perfect. Now we also can probably remove clear name, since we're not gonna need that, and then maybe remove the exports if there is any. It looks like we're fine. But if we carry on, you can see that all the elements in the elements folders, in the elements arrays, are unique, and the reason why they are unique is because they have a different weight. Now you can do your weights in your own way, as long as all these count up to 100. Now you see that the top one is 100, and that's just to cover for the use case that it cannot find any of the other rarities. But generally you'll start off by doing this, taking your top weight and putting it on top of the array, then working your way down and saying this is 15% and this is 5. If you count all these up, this should equal 100. Then what you can do as an added little bonus is just change the top weight to 100. This will still cover for creating something in that layer if it cannot find anything else. But that being said, I've done this all for the alien race. Now I'm going to do the rest of the code just to adapt it so that we can see if this will actually work. The next thing, like I said, you need to make sure that everything is exported right here at the bottom, and indeed we have. We need to go and import this now in our index.js file. So go ahead and let's go and import it over here. We are going to replace the rarity weights with the race weights. So what we can do is maybe say Command F, that way we know where we have used it, and remove it over here in the imports because it doesn't exist anymore. We can go ahead and just save the files and also take out the rarity here because we don't have that in this file. Going back to the index.js, let's go see where we are using it. We have created this function that gets the rarity. This function is going to behave exactly the same, but instead of rarity, it's going to get the race. So I want us to kind of update these things as we go along so that we can actually get the race instead of the rarity. So what I want to do is just replace everywhere where there's rarity with race. So we have to use the race weights. We will turn this into race weight and use it over here. The reason why we want to update all this is just so that we have clarity on what we are doing and getting with this function. We have used this function somewhere, and that was down here in our main loop. So we got the rarity off the bat. But this time, like I mentioned, we're going to get the race from here. So we're going to call the race function. Next, I want you to change this also into race, and then do the search for rarity in the application. We can see that we actually used it quite a bit. But because we moved everything one layer up, we now need to just adapt each function. The create DNA method will be expanded to actually accommodate for the randomness of the layers. We'll work with that very closely just now. For the time being, just change that into race, as well as the construct layers to DNA. Then what I want you to do is go into the create DNA function, and let's change this into race as well, and here as well. Perfect. In order for this to really work, we need to adapt this kind of in a way to see if we can run it and just have it run as normal like we used to. And how do we do that? Well, first of all, if we look in our config, we have this new object called race. So we need to use this object, this race object over here with all the races in it. So let's go back and let's just do a test wherever we are using layer. So let's go and search for layers. We're using it in quite a few different places, but if we turn these options in the search on, we can see that we're passing it at least only down here. Perfect. So technically, if you think about it, we need to kind of pass in the race, the layers, and the race that was selected. So at this point, I think it's a good choice to now update these things, because we're not working with layers anymore. We have to work with the race first. So now we're going to pass in the races object and not the layers anymore. Similarly, we're going to do this for the construct DNA too. And that should be fine. What we can do now is go into the create DNA, and let's go and adapt this function to work with our races instead of the layers, like so. So now, taking a look at how we can update this function to utilize the race layers will be very easy. If we go back to the config.js, we notice that races have the layers elements already, like before. We just now need to know which race we are selecting. And we know that this will be a value that's been selected from this object, alien. So we can say that it should select a race. Let's go ahead and do that. What you want to do is you want to append the races in front of the layers over here. Then we're going to open the brackets and say that this should be the race that we selected. After that, you can simply go .layers, because layers is an existing object inside of there. Perfect. Now that we have that, we are looping over each layer and everything is working as expected. We might end up with a problem here because we simply replaced the race just to save our code from breaking. But now we need to really think about how we are going to deal with the randomness and how we are going to utilize the weights that we've set in place for us on our elements. Let's check how we can do that. Next, what we need to do is actually create a random value. So what we can do is, we know that we have this number that we are creating a random value from. We no longer want to times it by the length of the elements or the layers. We can times it by 100, meaning that we will get a random value between 1 and 100. So let's go and do that, and let's just say this is now random num, and we already have rand num over there, so this we can count as the rand elements. Okay, let's do it random element num. Okay, so now we have a random element num, which would be either 60, 70, whatever out of 100. So now comes the difficult part of selecting kind of and making sure that that fits inside of our use case. So how can we do that? Well, this is quite simple. We need to loop through all the elements that we have. So what we'll do now is we already have the layers, And inside the layers object, we have got elements. We need to loop through these and look at their weights. Let's go ahead and do that. So we can do, let's think about it, layer dot elements dot for each. And then we need to now loop through each element and do something with it. Now, this will be the case where we actually find a match and say that this is where the function should stop executing and then use that element. Before we used the value of the array, but we also have these nice IDs appended to each element, which we will be making use of. So what we can do is we say for each element that comes in, we need to match it to this. And that's why I'm also going to create another variable and call it num. And num is going to be equal to 0 right from the start. Now, num is the one that we push to the DNA array and that we're going to return eventually. So let's go and do the checks. What we want to see is if this is greater or equal to the element's weight. So what we can do is we can say if in there, and we can say if our random element num that was generated is greater or equal to the element dot weight. Now, this is quite difficult to understand, but it's going to go in here and it's going to get this. Remember what we said? We said before that we need to take 100 minus 15 to actually get the true proper opposite value to make sure that it is going to be greater than that and to get this actual rarity. And that's why we are going to be doing this in here. So technically all we have to do is say 100 minus this, and then once we have this, we should have the actual element that we want to select, correct? So that's why we're going to set num equal to the element.id, and there we go. We've simply now updated this function to work with the rarities and the weights that's being selected. This can now be made custom for your own needs. We are busy making this for Lunaland so that they can have all their rarities and as to their specification. We're going to now have to run this, but there is a few updates that we need to make going further down the line, especially where we are drawing the layers. Let's go update those functions before we run the program. So next, let's go and have a look at what we need to do. We need to go all the way up and remember to remove our layers that we are importing. It does not exist anymore. Then let's go down to our main loop and see what happens. Currently, we've got our race, which is fine, which was used in creating the DNA. This will ensure that we get unique DNA and is tested with our DNA clause over there. This should all work perfectly fine because we are just returning arrays with DNAs of values of which element was selected. The next thing that we do need to update though and have a look at is this construct layers to DNA. Let's go there. Let's make the necessary changes, and we know that we are passing in the races over there and the race in here. We now have to see how we can map through everything here to make sure that the correct element is selected. Again, we have this main loop, which is going to loop over an array. And this is easy. All we need to do is say that it needs to loop over the races, and then again, pass in the race that was selected, like so. Then we can say dot layers because that's what we have in our structure over there. Because remember, these races might differ from human, alien, zombie, and so on. Once we are inside the layers, everything should kind of work as normal because we do have the DNA. It's going to do a selected element, and over here in the layers object, it's going to try and find that element. So let's go and see if it will still do that. We don't have the rarity anymore, so we can omit this, but we do have the elements, and the elements will be exactly as it is right here. It would go and select the one which we have the index of. But now let's think about this for a second. We previously used indexes to kind of cover our DNA, but this will be the exact same index as DNA and use the value. And in that case, it would use the ID, so we need to find a better way of returning the element. We can actually use that by using the find operator. So what we want to do is let's just duplicate this to make sure we have a clean line to work from. We want to go and take this all back and say find, like so. What find will do is it will either return the element if it's found, or it will just return undefined. So we need to find an element in this array where the ID is equal to whatever we have. So let's go and do that. Let's declare an element as E, and we're going to simply say where e.id is going to be equal to the DNA array.index. Perfect. And that's all we need to do. It's going to find that element in the array, and it's going to render it on the screen. Hopefully this all works. Perfect. So this line of code will now do exactly as intended, where it will go into the layer, it would find the element where the elements.id is equal to whatever we've saved in the current index of the DNA. This should in theory work perfectly fine, but you know how it all goes, so we need to make sure that it works. But let's go ahead and see what happens when we run this. We might run into a few issues still, but I want to go ahead and run it and see what happens. We still get an error on here where it says layers is not defined. So let's go and have a look. Press Command F and let's go and search for layers. Perfect. So we can see that already from our create DNA, it can't pick up the layers. Let me debug this and get back to you with a solution on how to find it then. So the main issue here where we can see is a problem is actually on the layers object in the config.js, and that is a problem. So let's go there and let's go and check it out. Perfect. I think right at the bottom we forgot to take out our layers export, and that was what was breaking the program. I also went ahead and in the get race function added no race in here just to make sure that if nothing is selected, we do know about it in the logs. Perfect. What we can see now is that the first one that was rendered doesn't have a race, and that is true because we are starting our collection off from 7 to 12. We need to update that. So let's go ahead and update what we have here, and let's say that we want to render everything from 1 to 10 as alien race, and then change the end at to 10 as well. Let's run it again and let's see what happens. Good, we are making progress. We know that we have got the element 1 should be an alien race, but then it gives us an empty array, which is fine. This is our DNA. Undefined race cannot be found, so this we're going to go back, go and search for that, and this is the debugging process. It says that on the create DNA it can't find race, where we need to probably pass that in because seeing that that's the only place where we use it. And there, this is our problem. We're using race there, but we said rare instead of race, which is my mistake. So I'm going to update that and then see if we can run this program once again. Next, we're looking and seeing that we can't find the property path of undefined. So this is going down the rabbit hole, and it's understandable that stuff like this would break. The reason for that is because we've changed the way and abstracted the way everything works. So here we can see that the layer, it's trying to render the layer and then find the path, which will probably not work seeing that we don't have the layers passed into the load images. So let's go down to see where we are doing that. Well, currently all we need to do here is, because we are rendering for each layer, but now we have to kind of be smart about it. We have to pass into the layers. Not only do we have to loop over that, but we have to loop over the current races layers. So what we can do is we can say races, and then in here, let's quickly just see, we have the results coming back from there. We're looping over the result, and then inside each of the results we will still have a layer, because the layer gets constructed from this. So if we go back for just a second, this is where this should actually be returning an object or an array for us with a bunch of these values, which technically means that this shouldn't really be an issue. And that's what I'm going to debug now, just to see why we are not getting any values returned. In order to debug this, what we can do is actually console.log the results. And the reason for that is because we want to see if something actually gets returned. So if we do that and we run the program, we can see that we are busy with ID 1. It's alien. It does have no DNAs in the DNA list yet, which is fine. But this is the problem. We can see that all our elements being returned sometimes have something in it, and sometimes it doesn't. And this is exactly what we want to work with. So let's go and see why that is. So if we go up, let's go up to where we are actually concatenating everything, then let's go and see. So we still have this location, the location that's being returned, and we notice that if the location is empty, we can't seem to find our element as well. It's not always the case, because there's a location that's undefined, and it looks like location is going to stay undefined, and the reason for that is we don't have location anymore in our layers. We only have name and element. So we can go and get rid of the location over there, and let's see if we actually get the element that we need. So it's weird to me that sometimes the one comes through where the weight is 100, but then it doesn't go and select the rest. It might select 100 lunar flag and all these things, but it doesn't select everything that it should. So the next thing that we need to do is actually where we do have this construct to DNA thing, we need to kind of see where we're going wrong. This might be the case where it might go wrong here, where we select the random element, but I want to go and first log out everything in here. So what we're going to do is, as soon as we get into the function, I want to log out the actual DNA. Let's go and do that, and let's run the program again. So what we have here is a 0, 0, 2, 4, and then we get another one. So let's go and see what happened. Over here in the first array, we actually got to the point where we said this should be following ID 0. Now, if we go and have a look at our configurations, there is an ID 0 for the elements in the background layer. So it should have technically chosen this element, but it didn't. And that is what we need to now figure out why. Let's have a look and see what's happening. Well, first we go and find an element ID, where that is what we are doing after we are mapping over the races. And this kind of works because I know that we are getting it in some places, we're getting exactly what we need. So that is no issue and no problem. I think the problem arises over here, where we are definitely not getting this equal to whatever this might be, whatever the value might be. So let's go ahead next, and inside this loop, console.log that. So we're going to console.log this as is. And actually, let's console.log this whole thing. So I'm going to copy and paste that inside here. Perfect. Let's just make sure I copy everything and put it in here. this should either give us undefined or should give us the object. And here we can see, as expected, we got undefined, and this is on ID 0, but then on ID 8, something interesting happens. We do find the ID where it's 8, and we do find the ID where it's 6. Now, it makes me think that the reason why it might find these two and not the rest is very peculiar. This carries on, and then it also has 0, 0, and 9. So then 0, 0, and 9. It makes me wonder if the zeros are a problem and that it might not find it. Let me think about this for a second, and let's get down to what we need. I think there is a problem with the generate DNA. You see, when we generate a random element between math.random, I think it might not pick up that there's a 0. Let me debug this, and then let's see how we can resolve this. I think a good place to start off with is changing this console.log into actually all the elements that is in this current layer. I think this will give us a better oversight of why we can't find what we are looking for. And if we look inside the folder structure, we should be finding this very easily, because there indeed is the value that we have, and it's going down and it's going down, so we have all of them, and we see that we do have an ID of 0. So for the life of me, I have no idea why this is not working. And I think I know, and I see the problem. Over here in our find, I see that I'm saying E is equal to ID and not the equals operator. And I think that is the cause of this all. And if we run it again, there we go. We actually loop through everything. And if I go down to the actual elements that was created, we can remove this now. Let me just run it again. And there we go. We said that we wanted to select element 1, and indeed it did. Then 0, and it did. And so forth and so forth. Everything seems to be looking very good at this point. We did find a error where it says no such file exists, and that is perfectly fine. I think this will obviously arise if some of the stuff is misspelled or mistyped. So I'm just going to fix that, but that is not an issue that you guys might dive into. So let's just go and fix that, and then get back to the code and run it and see if it will work. So like I mentioned, it's all about the spelling and we need to go and get that right. So let's just go up to the very top of our backgrounds, and it was electric, like so. Hopefully this resolves it. There might be some other issues that we arise in for the other ones as well. So for instance, we can't find the regular on suit, which is on the alien suit. And do we have one? Boom, that looks kind of the same, so I don't know why this might be a problem, but we've solved the first one. So I just want to see if I run it again, if we're going to hit a different error. And no, it still finds this one. It still can't find that one. So okay, there we go. We have suit instead of suit, you know. So that's something that you guys just need to take care of, because it is very intricate. It is very manual now, but once you've set this up, this should be catering for all your needs, like I said, and be very, very custom. So it looks like stuff is running actually, and actually creating some images. I will be quite confident to say that if we go to the output file, this image here should be working. And indeed it is. So some of them don't have heads, which is understandable. We're going to get to that part in a bit. And the reason for that is some of the races don't work with some of the hair types and those things. But here you can see the start of the Lunaland NFTs and the creation of them coming to life. And the metadata going along with that is going to illustrate how the rarities were picked, and we can make the metadata so it shows up on OpenSea. Hopefully everything works out perfectly, but we're getting there and I'm really excited. So let's go and see why the images don't work with some of the other ones. Let's remove them and let's run this program again. A lot of debugging, a lot of things that we've done in this kind of video where I show you how to customize things to your needs. And I hope you have loved it so far, following along. I know this might have been one of the confusing videos, but it's understandable because up until this video, the program might work for anyone's use case. And in this video, we're making it custom to Lunaland and how they want the NFTs to render. But that being said, we've covered the alien race. And the next thing that we need to do is actually clean up the elements that an alien can't have. For example, everything is now fitted in. I also added the skins and the headwears. So if you look at what was exported, was this cool looking alien image. But when we go down the ranks and look at the rest of our aliens, you can see that they have these different hairs on them. First of all, the hair won't fit on an alien, and the head is too big. And that's why we have the different races defined, so that we can take off the facial features or anything an alien can't have. And that's what we're going to be doing, along with adding the human race, zombie race, and so forth. And I'll show you how we can then export that and everything working. But it's very simple, and all I'll be doing is if I go and say for my alien race, seeing that this is all the alien race stuff, I'll just simply go and minimize whatever is in here. For example, I'll maybe take all these out and maybe have a no object, no hair object, or whatever it is. I think there is a no hair down there, and that's perfectly fine. So what I'll do is I'll take everything out and only leave the no hair, and then change the weight to no hair to 100 for the alien race only. And then for the human race, we'll leave it all as is, and so forth. And that's what we're going to be doing. The last thing I just want us to see is how do we add the metadata now to work with OpenSea. If we go onto the browser, we can see that metadata, in order for OpenSea to read it in any marketplace, you need to specify your attributes in an array with trait type and value. And that's what we can add to our metadata to work like this. So we can copy this example just like there. We can go back, and in our metadata currently, what it exports for us looks like this. And we need to update this attributes array to be more specific to the OpenSea's specification, so that it can work there and also on other marketplaces. Let's go quickly implement the metadata before we sort out all the race files. What we'll need to actually change the attributes like we want the attributes to look like, it's fairly simple. We can go back to the index.js file and see where we are concatenating our attributes. Now, we would like the attributes to look something like this, which we already have the array. So if you go to the metadata, we already have the attributes over there. Next, we just need to make sure that the attributes follow this structure with the traits and the value, where the value would actually be the name, so we can go ahead and update that to that as well. Then for the rarity, we're not going to have the rarity, so what we can do is just maybe backspace that, and then we do need the trait type from where it's coming from. So in order to get the trait type, which we need, which can't just be base all the time, we need to have the layer's name. Now in our experiment that we've done is we do have the layer's name and the name of the layer. So that's also simple, and then the only thing we need to do is say element.layer, which we can replace here, .name. And once we've done this update, if we run this program again, we'll start to see that the actual metadata starts looking more like the metadata that OpenSea and all the marketplaces expect. So let's wait for this to run. You'll also notice that it runs a bit more slower this time, and that's because of the amount of time that it loops through each element to make sure that it picks the right rarity. So just bear with that. I know the program is intended to be very fast, but when you deal with all these different rarities and you need to make sure they are rare, then you might run into a few problems. Perfect. We can see that the censored is picked. We still need to sort out the layers though, but that's not what we are looking at currently. We're looking at the metadata. So once we've saved this, we should have metadata looking like this, where there's a value and there should be a name as well. Now, I don't know why the name didn't come through this time, so I'm going to go back and see what did we do wrong. We indeed have the layers name in here, and I don't know if there is a layers name existing in here, and probably not, because when we construct our element over there, we don't put in a name. So you have to actually include the layers name in here as well in order for it to pick it up on the other side. Let's do that, and let's quickly run it again, and we'll see what we have after running it. But like I said, guys, so even though this might be the last customization of this code, feel free to contact me whenever you get stuck and whenever you want to find out more how you can improve this code. This is now a custom build for Lunaland, and I'm very excited to actually be a part of their project in the sense where we get to create their NFTs. Apart from that, I just want to also mention that the tutorials going forward and the videos that I'm going to be creating are going to revolve around solidity, blockchain, getting you guys to be experts in the field. So I'll be creating a little bit of a solidity course after this, so stick around when you want to see that. When we go back to the metadata, we see that we now have traits and a value field, and that's exactly what we need for it to show up on OpenSea. We can see that there's a background, a suit, shoulder, pin, race, facial hair, mask, hair, accessories, and headwear. And each one is now chosen based on its rarity. I still need to go and clean up things like, for instance, alien patch, where it should be 2 words and so on. But once I've cleaned that up and once I've added the races, we should have a program that spits out exactly what we need. So I'm going to do that, and the last section I'm just going to run the program to show you how smoothly this will work. Once I'm done there, you'll be able to go and customize your own code to do exactly what we've done here today. Just a small cleanup before I go ahead and work out all the possibilities and which elements won't work with the other ones with the different races. What you can do is just basically take out some of these logs, for instance, logging out the results as well as the DNA. So let's go and see the DNA list we don't care about, and we can just save that. The reason why I want to do that is so that your logs becomes much more cleaner. You can see that it's creating an alien with this and so on. I'm going to stop the program for now and also just take out the log where it's logging out the actual DNA string. So what I'm going to do is we're going to search for all the console.logs like so, and let's see what we want to keep. We definitely want to see which edition we created and maybe also include the race. So created edition, that, and also let's add race. Let's say the race was the race that's selected, and that is fine. I think that should work perfectly. And then let's just see where the other console.logs are. We're logging it out there, which we don't need. We do want to log out the edition, but we do get it in there as well. So I'm going to take out that too. And let's go and see, and also logging out the DNA is going to go away. So we basically only have these 2 logs left. And that will create a much more cleaner way of us observing what's happening in the code. For example, here in the logs, it would say created edition 1, race alien with DNA, and so forth. And that's what we want, and that's much more cleaner, and we can see everything being built out successfully and nicely. Once it finds a duplicate, as you know, it will say DNA exists, it would skip it and retry that DNA. So in the next video, like I said, I'm going to quickly go and fix up all the layers, and then we're going to do a final run. So basically, while I was busy implementing all the races, you can see I have implemented particle, sensor, human skull, all the races that we need. I realized that, for instance, if we open alien and we open a layer, we're pointing to the aliens layer, meaning that I would have to have an example of each one of these folders in each one of the races, which is a bit redundant, and coding is all about finding solutions. So a solution that I found is if we move all this stuff out into the input field, so directly, so we can go from there up until to headware, and we can move it right outside into the input. Because that's all we need. We can get rid of all these zombies and these races in here. So let's go ahead and remove it. The reason why we don't need the races in the input is because we specify exactly what we need from those images inside our races object over here. So a good thing to do maybe now is to go and do a global search in here for anything that has alien-alien, right? And we want to replace that with the exact thing, but we only want to replace it with 1/. Let's think about that. So once we do that, you'll see that the directory changes into the dir directory that we are in, and it will immediately use whatever we have in there. You can then specify which images to use based on what you put in these elements arrays. That's just a side note, because I noticed that it got quite heavy, and when we do that, you'll still see that we can still be creating our images as normal and everything will work. That's just a little cleanup that I wanted to mention as we were going along. Let's carry on, and let me go and finish this up before we do the final render. Okay, finally, we have set up all of our races. We've cleaned up the input file. We've now also uncommented our race weights, where we want to create a few censored, particle, alien, zombie types. And those respective types will now work with the respective elements that they can adhere to. For instance, the alien, the particle, and censored, they can't have hair features. And this code will allow you to control that. Remember, with the addition size and the ending addition at, we worked out the spaces between what we want to render for each race, so we know we can control that rarity. And then what we can do is now just render them. I'm going to go ahead and actually just run the program at the bottom, and you'll start seeing us creating them. Here at the first line, you can see that we've created a race censored, then it starts with the particle race, and then so on. It's going to create 2 censored because we said 2, 3 of the particles, a few of the aliens, and you can see it's already starting with the aliens. Let's go ahead, while this program is creating the files, let's go and open one. Let's click on the first one, and indeed it is a censored race. The second one should be censored as well. And just by looking at it like that, you can see that everything is working perfectly. So we can click on number 3, 4, and 5. These are all particles. 6 is also a particle. I think from 7 it should start to be an alien race. 8, 9, and 10, all aliens. And the further down we go, we start getting zombie races. And then the more further down we go, we should start getting the human race, which should pop up just in a second. We also have a skull race I see at the bottom. So we start with the skull races, and then after they are done, it would start doing the human race. Now, this is just the beautifulness and the magnificent thing that we've done. We've implemented these rarities. We've implemented everything we needed to do. And I'm very excited to go and call the guys from Lunaland and let them know that we can start creating these beautiful NFTs. I really hope that you guys enjoyed this series. I really want you to go and check out lunaland.io, check out the project, and we will be making more videos with them, so I will definitely be showing some of the NFTs, and I'll be definitely getting myself these NFTs too, because they are rad and they look very, very cool. That is all from me for now, and basically guys, I know there has been a lot of questions of people wanting to know how to now upload your edition sizes that you've done here and upload it to the cloud. Well, not cloud, but blockchain, right? How to mint these NFTs on the blockchain. It's very simple to do, and I will make an updated series on how to do that exactly. I will also, like I said, be making a series on solidity and how to learn solidity from the start. So stick around with me, and I hope you guys are going to enjoy the journey with me coding on YouTube, and I'll see you in an updated video, but cheers for now.